Holy sh**. Hi, I'm Tommy, and this is my slightly modified Ender 3. Today we're going to be upgrading even more of it, and hopefully finding its limits. Let me bring you up to speed. Over time, we've installed Klipper, doubled the Z-axis, added a touchscreen, blew up the mainboard, tried adding carbon fiber, a lightweight extruder, and a medium flow Hotend, which quickly got swapped for something a bit more powerful. Now that extrusion is sorted, the only things left are cooling and motion. Let's knock them out. Currently, my Ender 3 is operating at 24 volts with stock motors and a slightly modified Y-axis thanks to the carbon fiber plate. I think the first thing to change is to add more carbon fiber and get the heated bed added too. I bought this ages ago, but because I was shipped the wrong carbon fiber sheet, I wasn't able to use it until now. As I bought this linear rail from AliExpress, I'd like to install it first before testing the upgrades. Already we're looking at an improvement over stock, but before I test it, I want to go one step further and double the voltage. Doubling the voltage increases the torque curve of the motors, allowing for even faster movements. We need a 48 volt motherboard, 48 volt drivers, and a 48 volt power supply. Big Tree sent over a bunch of components including a few LDO 2504 AC motors, meaning we'll have a lighter gantry with more powerful motors at a higher voltage, and it's going to be awesome. I really don't want to fiddle around with more cables and mounting, so I'm actually just going to remove this and use sensorless homing. I've never done that before. I've got these parts that I printed on the Ender 5 that is slowly falling apart. Now I just have to figure out how to install them. These are all printed out of carbon fiber PETG from Marvel 3D. Okay, so I'm pretty sure this piece goes on like that, and then this piece goes on top like that. Luckily, I actually have the perfect length screws. They're not socket caps, but they'll work. So the CAD shows that we need an idler right there. I didn't actually order anything for this, but I've got so many spares. I think we'll be alright. Normally I'm afraid to do a project if it has a bomb, but I've never been so confident that I didn't even look at it. This is such a solid assembly. I'm not used to printing at such high infill with such exotic filament. Literally, the most I've ever printed was ABS, and that was 5 years ago. This is carbon fiber PETG. That's so cool. Always good to have a few on hand. Oh, I made a mistake actually. This uses M3 idlers. Now that's funny because I bought these M3 idlers like 3 years ago for a custom printer. Never used them. Now they have their time to shine. Okay, so now that I've ordered so many screws, I'm not running low on them. But M3 washers, that is something I need to buy lots of. I just need to slide the other washer in. I did it! Okay, I know that's slightly cursed, but it's completely flush. It's very cool. I'm gonna have to steal some components from the Ender 5 build. I'm running a bit low. There's actually everything in here, socket screws and all that, but I mean, it's for the build first. Workbench is warming up, that's a good sign. And this part here, we've just added the heat set inserts. You can watch the terrible overhangs while I get this one in. Well, there was no part cooling. Oh, I finally did it. That was a lot more difficult than I expected, but once again, completely flush screws. That's really cool. Ah, okay. Major mistake number 1. This is on the wrong side. All right, take 2. There we go. Okay, that is solid. Starting to look really cool too. Oh, so I don't need all these fancy parts. I just need this for the sensorless homing. All right, and then I guess we just slide this part on. Oh, that fits on amazing. That's so satisfying. You're meant to use V-slot nuts instead of rock solid. Brilliant. Looks great too. So that smaller belt is the stock belt, and that larger one is a spare Gates belt that I had. We're gonna have to use it since the stock one was too short. And I think it's now fitting to install the linear rail. Having the screws completely flush is actually insane. And they aren't making contact with the block, which is good. I think it's now time to install the Y-axis carriage. Right. That's definitely the most exciting part of this build. This box is so light. It's like there's nothing in it. Always a nicely packed. Oh, I can see the gantry. Wow. Whoa. You can see that this one, much bigger, and it's actually the right size. As I mentioned in the carbon fiber video, I was shipped the wrong size. I would have, what was it, 250 by something. Original heated bed, 483, and gantry, 733. Original carbon fiber with gantry, 421. New carbon fiber. Wow, that's actually insane. Here's the total new, 853, and the total old, 1.28. Huge difference. I don't need any special adapter because I designed a mount straight onto the part itself. And that's the final screw installed. As you can see, the new carbon fiber sheet is missing a chamfer, which is a little bit of a problem, so let's solve it. After this little message about PCBWay, the carbon fiber shown in this video was laser cut by them and was my inspiration for this project. They have many different manufacturing options, so if you require custom prototyping, I'd highly recommend checking them out. PCBWay is currently hosting their 7th design contest with huge prizes to be won. If you want to have a go, entries are open until the 19th of January next year. As always, there's a link to them in the description. I haven't used this drill press yet, so hopefully I'll figure it out quick. I've always wanted one of these. Oh, wait, wrong side. Alright, time to add the mains silicone heater. Doesn't really matter which orientation we install it, but we do have to get the holes to line up. That's going to be trickier than I thought. Oh, I have an idea of how we can do that. By installing the screws on the other side. Oh, it's actually working. This might be one of the few things I get right in this video. Wow, I actually did something good for once. This is where I tell you guys to subscribe. Also, if you're wondering about the max temperature I can achieve using this bed, here's the max rated temp for this bed, and here's the max rated temp for the carbon fiber. I can't believe we're installing the bed after all this time. Okay, now we just need to install the back ones, and that's it. Oh, that looks so cool. And now to install the leveling knobs. And with everything screwed down as well, all of the bolts are flush, which is awesome. Near perfect. Oh, that looks incredible. My Ender 3 has never had a PEI flex plate, let alone a mains heater. It's like a sandwich. It looks so cool and I hope it performs accordingly. So I was going to do the thermistor wiring, but we do have to replace the main board, so I'm going to leave it for a little bit. I've done the mains bed though. You see those over there? That's our ticket to 48 volt performance overdrive. This is going to be crazy. These are the LDO 2504 AC stepper motors and they are absolutely amazing. I used them on my Ender 5 build and I'm going to be using them here too. I have 2 for this machine. You may notice I've already got 2 installed over here, but actually I've got another 2 over here. So I'm hoping you can guess what that means. But that's for the next project. Let's focus on the current one. These ones are super annoying because they've got the idler pressed onto it. Oh, I didn't actually buy any of these. I'm gonna have to borrow some from another machine or something. Okay, I found 2 spares. Surely they're not needed later though. So here's the size difference between the stock and the LDOs. Just to put this into perspective, we're gonna be going from this on a stock main board with no current control, I don't know anything what it's running at, to running at 2 amps, at 48 volts, with larger motor, with a carbon fiber bed. It's gonna be so incredibly stupid. I'm so excited. Okay, looking good. Here's a closer look. Motors are one of the easier upgrades you can do to your machine, which is nice. A lot easier than, let's say, replacing the whole main board or such. Although that isn't too hard anymore. Larger motor, more current, and at 48 volts. This is going to be amazing. What's going to be really funny is we're going to have 2 power supplies, one on the left, one on the right. Although I think it was Mellow, they recently released a new product that allows you to get 48 volts from your 24 volt power supply. I will show that on the screen and show what it does. It seems pretty interesting. Oh, I forgot to uninstall the end stop because we are going to be taking it off. And I also realized I forgot to do the snap transition earlier. Now we can finally get rid of this super annoying cable and we'll only need the stepper cable that came with the motor. And I'm just going to do a fancy transition here. So I was going to install that new idler, then I was like, oh, where is my Allen key? You might be able to spot it. We can actually put this part into storage and save it for the Ender 5 build, which will be cool. Alright, finally time to install the new mainboard. It's so nice and tidy in there. It's a shame we're going to have to ruin it. Okay, it's now time to steal the main board from the Ender 5. It'll be getting a bigger one anyway. And as much as I loved my previously installed SKR Mini E3 V3 in the Ender 3, I really like the Manta E3 Easy. It's got so many more features. I kind of have to redo the Ender 5 in the next video anyway, so I might as well just uninstall everything and figure it out later. The reason I uninstalled the Raspberry Pi is because we're going to be using the CB1 for Klipper. It's really compact. I think I might actually uninstall the bed to make this a bit easier. The last thing I want is to make wiring harder than it needs to be. That is already so much better with plenty of extra room. I just realized that there's a mini HDMI port that I probably could use for the screen, but I'm still going to keep it off. This goes in... Okay, so it's a little bit later in the day, and I think I'm going to leave the wiring for tomorrow because I've made that mistake before. The first thing I'm going to install is the Z install. Oh yeah, and with great power comes great electricity bill. So I bought this new power supply as well. It was really cheap, but it's 600 watts, and I really don't need 600 watts. Before we install the X and Y cables, I actually need to swap out those drivers. These are the TMC5160 RGBs from Bigtree Tech. They're a lot bigger, and they have a much larger heatsink as well. They look really cool. And because we're using the Easy Driver system from Bigtree Tech, it is super easy to swap out the drivers. Here's a little size comparison. They're quite different. A lot of extra cooling, which is really good. Installation is super simple, plus they can only go in one way. Just like that. Not only do they look ridiculous next to the little drivers, but they fit perfectly in this case as well. I really want to test those drivers, so I've plugged the machine into power, and we're going to test it in 3, 2, 1. Yo! They have a nice blue color. I wonder if that changes. That's awesome. And that's the extruder plugged in. Alright, let's get this unboxed. Okay, so currently I'm going to wire in a separate cord for the 48 volt power supply so that I don't turn both on at the same time, but I will look into it, but I'll consider merging the two in the future. I did print a mount for the power supply, which will keep it on the side, so we'll see how that performs. It's not perfect, but it looks really funny seeing two power supplies installed. We're so close to being able to power on the machine and give it a go. Alright, it's a new day and I've realized I forgot to adjust the jumper caps for 48 volts and for sensorless homing, so I'm going to do that now. So that's sensorless homing sorted. Now we've got to do the 48 volt jumper caps. So I'm just double checking, but essentially the jumper was on the two right pins and now I'm going to put them on the two left pins. And that's sorted. Now we have sensorless homing and 48 volts for the X and Y motors. I've never done this before, so there's a couple of details I don't know. So, turning on the 24 volt power supply now. Nothing's exploded. Lovely, love to see it. Now I'm going to plug in the 48 volt power supply. Oh, everything's all good. Power supply is spinning. Lovely. I'm going to turn everything off now. And I've found some improvements for the Hotend. Not the thermistor mounting, but that's alright. First, I'm going to wrap thermistor with Kapton tape so it stays in place. Nice. So Triangle Lab were actually generous enough to send me an STD6 Hotend, which is an absolute unit. I mean, it's as big as my custom one, with a bit less power, but they included a spare glass fiber sleeve, which we can install. It's not the perfect length, but it saved me from buying some stuff on AliExpress. So we'll just install that now. There we go. And that's our custom Hotend. Oh, it's absolutely crazy. Alright, so I think I'm going to install the fans like this, just so we can optimize the wiring as effectively as possible. Okay, I've just added the heatset inserts. Part's looking decent, but I definitely want to reprint it when this printer is operational. Finally, a use for the overly long screws that I have. They actually fit perfectly. That's nice for a change. Really solid so far. A little bit messy looking, but it's going to look insane on the machine. I've just fiddled around for a little bit and it's starting to work, but it's still very... yeah. I accidentally broke the back mounting point, so now there's a bit less contact, but it's currently decently rigid, which is good. I need to readjust the positioning a little bit so the wiring is a bit better. I think I installed them the wrong way. And the good thing is these fans only draw 200 milliamps, so we can use a splitter and plug this into the main board without a relay. And just like that, we can run 2 fans off a single connector. They're not as loud as I expected. Not bad. And there's a good bit of airflow too. Alright, I'm going to go finalize the wiring, install the bed and clean up my workspace. So currently I need to wire in a fan for cooling the drivers. I need to wire in the thermistor for the mains heated bed. And there was one more thing. I need to print out a bunch of parts, but I don't think that was it. So that little fan's not going to cut it. This bigger one isn't as powerful as I expected, so I'm not going to use it on the end of 5. But instead, we'll use it on here. I will keep the cover on for protection, and I've also got this fan here. The machine is looking amazing though, which is cool, except for the wiring. I damaged the top part of the duct a little bit. You can see there, so I'm going to have to reprint that too. Everything is operational. Well, I'm not going to push that. Not yet. So essentially what I have to do now is take the current configuration, remove it, replace it with the old one, and switch the pins. So for example here, step pin is PA14 on the end of 5, which is what is installed currently in there, hardware-wise, but it's set to PC2. So I'm just going to fix that all up. Alright, I'm a little nervous. I think I'm done. I'm going to hit save and restart. Oh, Klipper error. They were mainly caused by incorrect pin settings for the TMC 5160 drivers. I have no idea if I've set up sensorless homing, but we'll see that all soon enough. What a hilarious setup. I'm so excited to see this thing move. It's been stuck on that for a little while, so I'm hoping... oh, well, is it gonna... maybe it doesn't have a correct connection with the MCU. I think that's an issue. Found it. This is the line from the end of 5. I'm going to paste that into the end of 3 config. Surely. Yes! I'm a genius. To compensate, the wiring in the back of the machine is absolutely atrocious. Also, I'm not a genius. Will anything blow up if I turn this on? It's not doing anything. It just gave us a little error. Yeah, not working. That's probably because I absolutely blew up the thermistor. I plugged it into the fan port. Theoretically then, if I adjust the bed heater to, let's just say 40 or 50, that should work straight away, no issues. Yes, it is. Not used to a mains... this is my first time with a mains heated bed. I need to do a test on that. Wait a sec. Maybe I'm just a bit stupid. It's working. It can read the thermistor temperature thingy for the hot end, but it's not working. Possible incorrect pin? It's not working now. It has decided to fix itself. Very pleased about that. I forgot what I was doing though. There's no way that relay would have died as well, right? It's not responding. Maybe it's not getting enough another signal. It's all wired correctly. I am such an idiot. Editor, relay what I said earlier. I'm a genius. So, let me show you what happened. So you know how nothing was happening before? Well, if I do this, nothing will happen. But look, now the relay is turning on. I wired it backwards. How stupid am I? Oh, same problem as last time, the relay's just going up. Okay, well, I'm hoping that's a wiring problem. Oh, so it was a wiring issue. That means the relay in the other video, in the hot end video, was fine the entire time. I just couldn't wire it properly because I'm such an idiot. Damn it! As you can see, everything is working and I have blown nothing up. Alright, 48 volts is now going through the machine. It's now time to test out XY movement. And what's really cool is the easy drivers, the 5160 RGBs will change color depending on how hot they are, so I can easily monitor their temps. That's a pretty neat feature. I also have a rather stupid plan to make this entire 3D printer transparent using SLA resin, but I'm only going to do that if I can get a guaranteed amount of views on it, because it would be very expensive. Okay, homing x-axis. That's, okay, so that was the z-axis. What about the y-axis? That's the z-axis again. What is it doing? So what does homing z do? Oh, I home Z as well. Is it going to work? No. Yes. No. No. Alright, we made good progress today, but I just can't get this machine to move or home. Basically anything that uses the new drivers. That's something for tomorrow, hopefully. Alright, it's the new day, and I finally got the Z-axis working. Before, nothing would move, and now it actually moves and homes. I went into the firmware and I adjusted the enable pin, and now we actually have manual movement. Does it work on the y-axis? Yes. Okay, now I need to figure out the homing. So as you can see, the X and Y end stops are triggered. Well, the sensorless homing end stops. So I messed around and I inverted the pins, and now they're all working. So if I show you, this will crash though. But I got it working. So now I just have to adjust the sensitivity and we can get to printing. The process is literally typing out these numbers, increasing them every time until it works, and then I've got to do some math after that. But there's this awesome tutorial I'm following here, and it's completely saved me. So I've found that if I change the value to +2 and then execute a G28X0, watch this. It homes without an end stop. That is so cool. We can now successfully home X and Z, which is great. We just need to be able to home the Y-axis. I forgot to turn the fan on for the drivers, and now they're glowing red because they're hot. Well, the RGB LED is glowing red. I gotta take the power supply off and change the mount. It is not working. There's not enough clearance. So I'm gonna remove that now, and of course be careful when operating. But we've almost got the Y-axis working. I do want to reinstall it though, because it looks so good for the thumbnail. I think I did it. Watch this homing sequence. It waits a little bit per axis. Oh, that's so cool. There's no end stops. Okay, after redoing the wiring, it should work now. So if I drag this to the... Yes! We have fan control now. Alright, let's run a little timer for how long it takes to go from room temperature to 60 degrees. Starting now. Going from no heated bed to one that heats up that fast is absolutely incredible. I think this draws 500 watts. With the fans working, the homing working, the axis moving, that sort of thing. I finally got it up to temp as well. It's time to reprint some of the parts and then give it a tidy up and a full speed test. I'm very excited. It is good to see extrusion again. The cooling seems to work as well. That's awesome. Okay, I haven't got the Z offset properly dialed in, but that is a first layer. And I have noticed the 48 volt drivers, the 5160s, are actually a lot quieter than the drivers I'm used to. I've upped the speed a little bit to 10,000 millimeters per second at 400 millimeters, which should be no problem for any of the motors. And this will be a good little test of extrusion and cooling. I really shouldn't be pushing the machine like this already after parts aren't fully tested, but it's good fun. The first one failed, of course, because I tried to run 21,000 acceleration at 1 amp, just because the Ender 5 topped out at 20,000, but I know we're going to get past that on this machine. Alright, this is the 30-minute benchy, well 32, and it looks okay. It's passable, but if it's under 8 minutes, I would be a lot more pleased. Alright, so I was trying to hot tighten the system again, make it better, but one of the wires for the Hotend just came off. I'm going to try resolder it, so it should be okay. I'm really not sure what to do here, since I can't solder in that additional wire. The easiest solution would be to remove that side of the heater. So that's what I'm going to do, and yeah. This means we are going to be running at 115 watts instead of 230. Which means we could run it off the main board, but I've got everything wired up, so I'm going to keep it as is for now. I do already have a similar length heater for V2, but I didn't want the Hotend to be just a one video project, but it should survive. It should survive. We will persevere. When I was making the criteria for this Hotend with repairability in mind, I didn't realize how soon I would be repairing it. Alright, currently trying to heat up to 220 degrees. This is my absolutely atrocious setup that's holding the block because I need to remove the broken one. I also need to remove the old heat break. Let's see if it works. I was able to do it. I got that heater off. There's the other one. I'm not going to touch it because it's swelteringly hot. I was actually able to loosen it. It turns out it's a lot hard. Well, I know it's a lot harder than I expected, but I can't believe I was able to do that. All right, I have reassembled the thing. I forgot what it's called. It survived the power on. The next test will be seeing if it survives a heating up cycle. Heating up in 3, 2, 1. Whoa, 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 something's smoking. Do you see that? What is it? What is it? Is it the filament? All right, I'm pretty sure I just cleared the PTFE tube of the blockage. Let's get to it. Okay, we are fully assembled once again. Time to give power to the machine. Wait, oh. I'm gonna be wrapping up today's work soon, so hopefully this works and I'll be very pleased if it does. A good ending. I'm so happy. Wow. This is what's going to save us. The parts aren't terrible, but they're not good, and the Hotend is still, after all that it was leaking, even after replacing the heat break. So I've got a solution, and it involves that. So it just sheared off. I really hope I can get that out, otherwise I'm stuffed. It's almost like it's not possible for me to not make some sort of catastrophic mistake in each video. Last video was the water cooling and shorting out the small Hotend. So I only have one option now. I didn't want to do it because I wanted to save it for a future project, but Triangle Lab did send me something and I think it's gonna save us. So bad at this. It's unfortunately time to say goodbye. They say conflict makes good storytelling, but maybe not in this quantity. The Rapido Ace also uses a ceramic heater, like my design. We can use an melt zone extender, and we can also use a CHT nozzle, so we can get the most out of this Hotend. And this is what it looks like. It's actually quite a big melt zone, not as big as the other one. And there we go. The melt zones both start here, and this is almost as long, but it's got about 80 watts of power instead of 115. It'll still perform great though. That is super rigid. I didn't take into consideration if the extruder mount could fit around the Hotend mount. Hopefully it does. After quite a bit of trial and error, I finally was able to get it mounted and get the, can you see that? PTFE tube straight. There'll be a whole lot less pressure if one of my machines worked, but currently nothing is in service. So I've just got to make do. All right, I'm powering everything on. That fan is supposed to spin. Not sure why it's not. Oh. Maybe that's why. All right, take 2. There we go, much better. I've never used a PT1000 thermistor before, but by switching the Klipper config, which is super easy, we're back to working. This one heats up so incredibly fast. I really should get one of those Newton meter wrenches. All right, let's give it some filament. Success! For a part with next to no cooling, that's not too bad. I do need to print out those ducts now, so let me just redesign a few more parts. This is my first prototype of a new tool head. It's got integrated cooling. I need to adjust mounting for the fans, but overall it's not as, well, yeah, I'm gonna do V2 now. Here it is, printing out parts for V2 of itself. Those parts turned out actually pretty well. I haven't cleared all the supports, but the part is looking really good, and each one I print will improve the print quality even more. So we need to mount this fan to this plate here, but first we need to connect the wires to the 12 volt converter, because this is a 12 volt fan and that is a 24 volt mainboard. All right, I've wired that up somewhat nicely. Let's get it installed. 3, 2, 1. Sweet. And we can still view the motor driver temperature in the back there with the LED, which is good. At this angle you can see both. So yeah, I'll keep a close eye on them and see how it performs over the fan. Well, this fan. Currently, I've only got the driver set to 0.7 amps, so you can't really see. So they won't overheat like this, but we'll have to see how it goes at higher amperage. I also spent a good hour or two designing a custom belt tensioner for the y-axis because I'm so sick of this. It's essentially this part, but with a tensioner built in, and I'm really proud of what I did for once. Bit hard to see, but the print quality is looking absolutely amazing currently. I'll show you when it's done. I don't know why it's suddenly gotten so much better, but it's going to get even better after this. Printing well, but there is quite a lot of ringing. I might have to run input shaper, but not sure just yet. There's my custom designed tensioner. The print's certainly not perfect. It's got quite a few, under that light it looks terrible. And it's a bit flexible as well, so we'll just have to see how it performs. I might have to reprint it in something else. Well, I don't think it was strong enough. I'm going to reprint this with a different orientation. For some reason, the layers aren't very... Oh, so now these ones are strong. Never mind. That is just regular PTG, and it has turned out so nicely. Still some ringing, but really good layers. After spending an hour getting this installed so that I could reprint this, we can now install it. Let's do it. So it turns out I actually forgot to include these spacers in the design. Now let's test it. That has got to be one of the coolest things I've ever designed. This project is like 80% making this machine fast, 20% building this belt tensioner, and I'm so proud. Not sure if it's easy to show how much more tension there is, but this is already so much better. Oh, I made a mistake. The whole point of designing that was so that this could be rigid mounted, not groove mounted. I even half remembered to add cutouts for the Allen key so I could screw these bolts in. It's a little bit fiddly to see, but I've started getting the first bolt in, and the hot end is connected to it. This is my first time with a rigid mount hot end. It's also a lot shorter now. That's looking awesome so far. Now I know why they call it rigid mounting. This thing is so solid, it's incredible. Alright, I finally installed the extruder. I actually had to use a threaded tap and re-thread the brass inserts since the bolts weren't going in. That was pretty cursed. It's working great now. The machine's going to look so cool, all stealth black. Alright, now we can install the fan ducts, and then we should be all good. Brilliant. It looks really good so far. I just need to reprint that duct, organize the cables, do a few other things like print out an end cap there. But yeah, we're nearing the end now, which is awesome. This terrible end stop solution I've got, so I'm just going to install a spare one from the Ender 5. That is so much cleaner than before. A bit harder to get the parts off at the front of the build plate. Because I need to access the USB port on the main board, this is the setup I have to do, and because the fan won't fit, I have to get this fan out. And here is the input shaper we'll be running. I'm going to attach it to the extruder, and then I'm going to, stick it to the bed. This is slightly cursed to see, but nothing's blown up, so I'm not complaining. That is 500 millimeters per second at 50k. I have never gone that fast before, not even on the Ender 3, the Ender 5. That thing managed to do 400 millimeters at 20k, barely. So we seem to be smashing that, but also I ran input shaper on this machine and not on that one. A lot of variables. We have successfully hit 100,000 millimeters per second squared acceleration at 500 millimeters per second travel movement. There's not much point to going any faster since we're 500 millimeters off the bat. Look, 500 millimeters at 300k excel. We're just constant 500. It doesn't change. That's incredible. Alright, oh, when it does that, the whole table shakes, you can see it. So we're running at 50,000 acceleration at 450 millimeters velocity. I don't know why it pauses slightly at the end of each layer. We could save some time if we stopped it from doing that, but I don't know why it's doing that. The key to getting these higher accelerations was running input shaper. I was maxing out at 20,000 before, now I'm at 50,000. And as you saw on the speed test, I got up to 300,000. Which is stupid. I don't think it's any more effective at 500 millimeters. So I just wish I did that on the Ender 5. We could have got even more performance out of it. But at least I know now, and when we do the all-wheel drive conversion, it's going to be even crazier. 2 minutes in, a little over 2 minutes. These 24 volt fans are not as powerful as I expected. I have some 12 volt ones that are probably double as powerful. That's what I thought I was getting. I double checked everything. But yeah, I can always swap them out for something even crazier, but they're good enough for now. A little over 3 minutes in, 4 minutes in, 5 minutes. I think I'll try one more quality run, one more speed run after this, and then do one quality run. I'll get ready for these travel moves. Yeah, that was insane on the Ender 5. Just as good here. Alright, so we'll get sub 8. That's good. Faster than the Ender 5, but I know that this machine can do a bit more. 7:24. A minute and something faster. A minute 20. Yeah, not too bad. I've got the Ender 5's 843 handy. Here it is, 843. Let's do another speed run. I'll just mark this one real quick. So what I'm doing for this round is I've upped the minimum cruise ratio to 0 and the square corner velocity to 20. Before it was 0.5 and 5. It starts so quick I have to be ready to start the timer. Let me just adjust the angle real quick. Oh, there's the shake. Wow. Oh, it just came off the bed. Alright, take 3. Third time's the charm. We got this. Sub 6, come on. Oh. Barely made it out of there. Oh, I didn't even get the blob. Oh, there we go. Bed adhesion is an issue at these speeds because you've got to have it stick so incredibly well. 1 minute in. It's definitely going faster. 2 minutes. It's always the little settings. I had no idea that square corner velocity and minimum cruise ratio makes such a difference. I think it's minimum cruise ratio that makes the biggest one though. 3 minutes. What layer are we on? Layer 67 out of 192. Oh yeah, and for temps we are running 240 on the hot end and 64 on the bed. And this is Jamhay high-speed PLA Plus. This stuff is really good. I think I just heard one skip from the motor. We are 5 minutes in. All it just needs to do now is the roof and the smokestack, and then we could get sub 6. Come on, I want that sub 6. Yes! No way. Come on, come on, come on, come on, come on. Yes! 5.59. 5.59. That's 2 minutes and 44 seconds faster. Oh no, I squished that. Oh, come on, come on. Is this cheating? I don't know. This is a sub 6 minute benchy. He looks very fitting for that time. Okay, let me pull up the 724. Can I get those both? Yep. There's a noticeable quality difference. And the legendary 8 minute 43 on the Ender 5. You can see the little layer shift. I guess I just have to do it again with the current increased. For now, let's do a quality run. This will be a quality benchy, about half the speed of the other one. I'm hoping for a sub 15 minute quality-ish looking benchy. It always struggles with extruding a little bit on the first layer, and then it just works. So I don't know what's up with that. It's not shaking as much. So it's basically going to go slower on the outer walls, fast on the inside, but overall not as fast as the previous settings, of course. I'm really excited to see how this will go. The front of the boat curls up a little bit. Not sure what's up with that. I borrowed the settings from this speed benchy video here, so we'll see how my hardware compares to his. I think his cooling is better than mine. I should have lowered the filament temperature. I'm going to do that now, 230 down to 220, just because we're not printing that fast, so a lower temp filament should cool better, I think. I don't know. This is still double or triple the speed I would normally print something on, but if it prints this well enough, which it seems to be doing, I mean, I have no reason not to use a profile like this for my other things, for my other prints. Oh, I didn't enable retraction. 5 minutes in. Yeah, I disabled retraction for the previous boat to save some speed. Hopefully we don't get too much stringing on this one. You can see there's a little bit of stringing on this boat at the front there. My square corner velocity is double what his was. I'm not sure how much that'll affect things, but I'm turning that down to 10 like he recommended. Honestly, I could spend all day dialing in the settings and getting the perfect 15-minute one, but if this turns out how it's looking like it will, I'll be very pleased. Oh, I wonder if we can get it sub 11. Gonna cut it really close. No, we're not. 11:08 on the dot. Not bad. Smokestack's a little worse for wear. Let me just mark that. I'll remember that. Not bad for no retraction. Surface quality isn't perfect, but the details are there, and it's certainly much better than the... Here we go. End of 5, 8 minute 43. Come on, focus. It's incredible how much a couple minutes of difference makes. Not bad. That's awesome. That's a success. It's a little under double the time of the 6-minute one here, but it looks completely different. We need a bit more cooling and overhang, but overall, very pleased. Overall, this project wasn't too hard, but still contained its fair share of challenges and setbacks, especially with the wiring problems due to user error and the hot end breaking halfway through, also user error. The carbon fiber components and LDO motors running at 48 volts really pushed the machine well, and I've never seen numbers so high before on my Ender 3. I know there's still room for speed though, and I didn't expect Input Shaper to make that much of a difference, but I'm glad I was recommended to give it another go. This project I'd say was a success and will help me with my next printer video where I redo my Ender 5 with enough upgrades to smash even my 6-minute benchy. If you have any advice or other ideas, I'd love to hear them as always. I think this will be my last video on the Ender 3. I've soaked enough upgrades, time and money into this machine. I have one final project planned with it, but of course we'll see if that happens. Once again, thank you so much for watching, and hopefully I'll see you again soon.